Yes, I think we started differential equation. Hello, Aryan. We started differential equation and I think we did some examples. The last example was a cos of log x plus b sin of log x. Can you tell me what was that example number? Yeah, please let me know the example number. Yeah, we did 4 examples. Okay, so we started with order degree, identify order and degree, and then we did these examples containing constants. So order is highest order derivative present in differential equation. Degree is its power or index based on what? It must be free from root, that means radical, that means negative powers, that means fractional powers, everything else, correct? Next is type number 1, formation of differential equation, and that is going to be number of arbitrary constants is equal to number of derivatives is equal to order of differential equation. So we started this. Let us move to now next type. So next example, we did 4 examples. Let us move to 5th one. Concentrate now. So 5th is, number 5 is y is equal to a e raised to minus 2x plus b e raised to minus 3x. And just check how to do this example. A e raised to minus 2x and b e raised to minus 3x. Nothing difficult. Concentrate now. Just concentrate. So we are going to work on this example now. A e raised to minus 2x plus b e raised to 3x. How many constants you find? 2 constants. So differentiating twice. 2 constants differentiating twice. Now a direct process is not applicable here. Yeah, order will be 2. Direct process is not applicable here. So I am going to do this like this. I will call this as number 1 and I am going to find first derivative y1. Y1 will be a as it is, derivative e raised to minus 2x is e raised to minus 2x into minus 2. B as it is, e raised to minus 3x is e raised to minus 3x into minus 3. I will call this as number 2. I got number 1 original, then first derivative, and now the second derivative, that is y2. I will go for y2 second derivative. This a as it is, e raised to minus 2x into minus 2 is plus 4. Then b as it is, e raised to minus 3x into minus 3 is what? Plus 9. And this is number 3. So we got it number 3. I just took both derivatives because there are 2 constants, so 2 derivatives. Still, adjustment is not possible. Why? Because you cannot take something common or you cannot eliminate a and b directly. In that case, we'll use the format of consistency of equations, if you remember. Correct? In consistency of 3 equations, we can form a determinant, if you remember. And this determinant is equal to 0. How to form this? First, we want to eliminate a, so write coefficients of a. What are coefficients of a? E raised to minus 2x, then minus 2 e raised to minus 2x, then 4 e raised to minus 2x. Then coefficients of b, e raised to minus 3x, then minus 3 e raised to minus 3x, then 9 e raised to minus 3x. So we got it like this. Now I will shift this left hand side to the right. So this y will be minus y, this y1 will be minus y1, this y2 will be minus y2. So I got it like this. And now in determinant, you can check a and b are eliminated. So this is the process of elimination of a and b if any other method is not applicable. Correct? So how to eliminate? Write coefficients of a, coefficients of b, and shift this on right. This is consistency of equations. Remember. How to solve this determinant? Take e raised to minus 2x outside. Correct? From this column. From this column, e raised to minus 3x outside. From this column, minus sign outside. So what left? Just check. What left is 1, minus 2 and 4. 1, minus 3 and 9. Y, y1 and y2. I have taken minus sign outside. E raised to minus 3x outside, e raised to minus 2x outside is equal to 0. If you find this carefully, this everything will be 0 here. Why? 0 upon anything is 0. So I need to solve this determinant. 1 into bracket minus 3y2 minus 9y1 minus 1 into bracket minus 2y2 minus 4y1 plus y into bracket minus 18 plus 12 is equal to 0. So we got it like this. Now minus 3y2 minus 9y1 minus plus 2y2 plus 4y1 minus 6y is equal to 0. So we got it like this. Yes, now I will just simplify this. What we have? 2y2 minus 3y2 is minus y2, correct? Minus 9y1 plus 4y1 is minus 5y1 and minus 6y, and I can just cancel minus sign throughout, so it's y2 plus 5y1 plus 6y is equal to 0. I can write like this also. y2 means double derivative plus 5 into single derivative plus 6y is equal to 0, and this is a required differential equation with order 2 and degree 1. Everybody understood this? Yes, everybody understood this? Yes. Can you all try this sixth one? Just check, quite similar. A e raised to 2x plus b e raised to 3x. Quite similar sum. Okay, just positive things. Yeah, try this. Yeah, I think you will get same answer, just this side is negative. Sabruddhi, you can multiply by minus sign throughout, so this will be negative. Rest all things are same. Correct, na? Same answer you will get. The middle term will be negative 1 for sixth. The middle term will be negative. Yes, chalo. We'll move to next examples number 7, 8 and 9. I will explain 3 examples now, 3 at a time. Check this, 7, 8 and 9. Yeah, concentrate now. Example number 7. I will just start these examples and then you all can start working on the solutions. I'm just going to explain the initial stage. 7, 8, x square upon a square plus y square upon b square is equal to 1. And number 9, ax square plus by square is equal to 1. Check what I am going to do here. Concentrate now. I will explain all 3, but I will start these examples. I won't explain complete solution because you know the process. This is number 1. Number 1, 2 constants differentiate twice. First derivative, y1 is equal to 2ax plus 3bx square. Number 2, again derivative y2, 2a plus 6bx, and this is number 3. And you will find constants have not eliminated. We took 2 derivatives, but still not possible. Go for determinant. How? Check this. I will form a determinant is equal to 0. And what's that? Coefficients of coefficients of a are, because a we want to eliminate, na? X squared, 2x and 2. Coefficients of b are x cube, 3x square, 6x. Coefficients y1 and y2 on the right side, that means minus y, minus y1 and minus y2. Now to simplify this, what you can take common from second column? X. From first column, nothing possible. Last column, minus sign. So what we have, just check. X squared, 2x, 2. Here x square, y, x taken common. 3x and 6, correct? X taken common. Y, y1 and y2. If you remember, this is going to be 0 on the right side. Solve determinant. Everybody understood this 7th example? Understood this 7th example? Yes. And now 8th one. This is your further process. Now you know this. Now 8th example. Check 8th example. Same process. I will call this as number 1. Now I will differentiate this x square. 2x upon a square. Differentiate y square. 2y, y1, nare. Chain rule. Derivative of 1 will be 0. Are you getting this or not? That's a chain rule. Y square derivative is 2y into derivative of y, dy by dx, 2y, y1. Again derivative, y, 2 constants, 2 derivatives. Derivative is 2 upon a square plus 2 into bracket, uv rule, y, derivative of y1 is y2 plus y1, derivative of y is y1, so y1 square upon b square is equal to 0, number 3. Correct? I'm just differentiating. And now I will use determinant. Why? Constant still not eliminated. 0. I want to eliminate 1 upon a square, not a square. 1 upon a square. So it will be x square, 2x and 2. Here I want to eliminate 1 upon b square. So y square, 2y, y1, 2 into bracket y, y2 plus y1 square. and 1 on left side minus 1, 0 and 0. And now what you can take common from the rows? From this row my 2, from this row 2. So what left? X squared, y squared minus 1 as it is. 2 common, na? So x, y1, 0. Here 1 because 2 common. Y2 plus y1 square and 0. Now you will find this will be 0 on right side. Solve this bracket and that's the answer. Yes, everybody understood number 8? Yes, now number 9 is nothing but 8 only. How? Listen to me carefully. Number 9 is number 8. How? Check this. What if I put 1 upon a square as capital A and 1 upon b square as capital B? Will it be same sum? जर मी 8व्या नंबर 8 मध्ये 1 upon a square ला कॅपिटल A म्हटलं आणि 1 upon b square ला कॅपिटल B म्हटलं तर 9 मिळतंय का बघा? Yes, I want you all to try these all three quickly. And that is 7, 8, 9, 10th question now. And this is important now. Mark 10th. X square plus y square plus 2gx plus 2fy plus c is equal to 0. Is equal to 0. And now check how to do this. Do you remember which equation is this? I think you did this in 11th or 12th. You know this probably equation. I think you did this in 11th or 12th. आठवतंय का? कुठलं इक्वेशन आहे? Circle, general equation of circle. Center minus g minus f. Radius root of g square plus f square minus c. Correct na? ते हे equation आहे. Okay, so how many constants? 3 constants, g, f and c. So differentiation thrice. I will call this as number 1. Okay, differentiating. Differentiating with respect to x, 2x, 2y, y1, 2g, derivative of x is 1, 2f, derivative of y is y1, derivative of c is 0, is equal to 0. I will cancel 2 throughout. So what I am going to get is x plus y1 plus g plus fy1 is equal to 0, and that is number 2. And here number 2 hai. So I got number 1, differentiate this, and I got number 2. Correct? Now again differentiating, because how many times derivative allowed? 3 times. Why? 3 constants, g, f and c. I did only 1. Now second. Derivative of x is 1. y1 will be y, y2, uv rule na? u derivative of v plus v derivative of y is y1, so y1 square. Derivative of g will be 0. So f derivative of y1 will be y2 is equal to 0, number 3. Still this is not enough. Why? Total 3 derivatives allowed. I did first derivative, then again second, again differentiating, because total 3 derivatives allowed. Again differentiating. 1 will be 0. This will be uv rule. Y derivative of y2 is y3. y2 derivative of y is y1. Correct? U derivative of v, y2 will be y3. V derivative of u. y1 square will be 2y1. Derivative of y1 is y2. Fy2 will be Fy3 is equal to 0. Equation number 4. We got it like this. After doing this number 3 and 4, I will go for solution of these two. But derivative number 1, derivative number 2, derivative number 3. I got 3 derivatives, but still this constant is there. Correct? हा कॉन्स्टंट गेलाच नाही, आपल्याला नकोय कॉन्स्टंट आन्सर मध्ये. मग मी काय करतोय बघा, ऍडजस्टमेंट इज मी या इक्वेशनला y3 ने मल्टिप्लाय करतो, म्हणजे 3 ला y3 ने करतो आणि 4 ला y2 ने करतो आणि मध्ये सबट्रॅक्शन घेतो. याने काय घडेल बघा. ओके, आय एम गोइंग फॉर सबट्रॅक्शन. 3 ला y3 ने, याला y3 ने मल्टिप्लाय करा, काय येणार? y3 प्लस y, y2, y3, करेक्ट ना? प्लस y1 स्क्वेअर y3 प्लस f y2 y3 इज इक्वल टू 0. मी y3 ने मल्टिप्लाय केलं. मायनस 4th ला y2 ने, याला y2 ने करा, काय येणार बघा? y, y2, y3 प्लस y1 y2 स्क्वेअर y3, y1 y2 स्क्वेअर ने, y1 y2 y3 ना, का y2 स्क्वेअरच येणार आहे. येस, आय एम जस्ट गोइंग फॉर मल्टिप्लिकेशन ऑफ y2. So y, y2, y3, y1, y2 square plus 2y1, y2 square प्लस FY2Y3. मी काय केलं कळलं सगळ्यांना? याला मी कितीने मल्टिप्लाय केलं? Y3 ने, करेक्ट, आणि याला कितीने मल्टिप्लाय केले? Y2 ने. दोघांची सबट्रॅक्शन घेतली आणि आता काय कॅन्सल होईल बघा. मध्ये मायनस आहे ना दोघांच्या, करेक्ट कसोरी? मायनस 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 हे कॅन्सल होतील, हे सुद्धा कॅन्सल होतील आणि एफ एलिमिनेट झालाय बघा. म्हणजे काय मिळालं बघा? Y3 प्लस Y1 स्क्वेअर Y3 मायनस Y1 Y2 स्क्वेअर मायनस 2Y1 Y2 स्क्वेअर म्हणजे मायनस 3Y1 Y2 स्क्वेअर, करेक्ट, इज इक्वल टू 0 अँड दॅट्स द आन्सर. एव्हरीबडी अंडरस्टूड दिस? कधी कधी या प्रकारची प्रोसेस सुद्धा करावी लागते. चालेल सगळ्यांचं? Yes. Now, let me explain example 11. How many constants you find in example 11? How many constants you find in example 11? 2. Can you tell me what will be the initial process before we begin derivative? Can you tell me what will be the initial step? What must be the initial step before we begin differentiation? Before we begin derivative? No. Can I shift this on left? So it will be y e raised to minus x is equal to a cos x plus b sin x. This is number 1. Why? Why? Because this UV rule is bit easy than this UV rule. No? Right side UV rule will be quite lengthy. Yes. Now can you please all try? Yes. Can you all try this one? Yeah, done? Or I need to explain. It is little complex, huh? Because on left hand side you can just check. Negative sign is there, huh? Every time. So you need to take care. So if I differentiating with respect to x, y derivative e raised to minus x into minus 1 plus e raised to minus x derivative is y1, a cos derivative is minus sine plus b sine derivative is cos. Okay, this is number 2. Again differentiating. So again differentiating minus into bracket u derivative of v plus v derivative of u. Correct? U derivative of v plus v derivative of u plus u derivative of v, v derivative of u. Y1 will be y2. Correct? Then y1 into derivative e raised to minus x into minus 1. U derivative of v plus v derivative of u is equal to minus a cos x minus b sin x minus plus y e raised to minus x plus will be minus y1 e raised to minus x plus y2 e raised to minus x minus e raised to minus x y1 minus common a cos x plus b sin x. Correct? And now e raised to minus x common, y minus y1 plus y2 minus y1 is equal to minus, this is original one, y e raised to minus x cancelled, y2 minus 2y1 plus 2y. Is this the correct answer? Just check. y2 minus 2y1 plus 2y. Is that the correct answer? One more example, example number 12. I check example number 12. Example number 12 is xy is equal to a e raised to x plus b e raised to minus x squared. Sorry, plus x squared. Tell me how many constants you find here? Tell me how many constants you find here? Two constants a and b. That means we have to differentiate twice. But before I start differentiating, I will rewrite this. xy minus x square, shifting it here, is equal to a e raised to x plus b e raised to minus x, number 1. Is that okay? कळलं मी काय ऍडजस्टमेंट केली? कळलं का मी काय ऍडजस्टमेंट केली? मी हा इकडे आणला. करेक्ट? आणि आता जेव्हा तुम्ही पहिला डेरिव्हेटिव्ह घ्याल, दुसरा घ्याल, तेव्हा हेच परत मिळेल ना रे. आफ्टर 2 derivatives you will get original equation again, number 1. Correct or not? दिसतंय की नाही? दिसलं पाहिजे तर सब मध्ये दूरदृष्टी पाहिजे, ओरिजिनल तुम्हाला दिसलं पाहिजे. करेक्ट? येस. स्टार्ट वर्किंग ऑन दिस. करून टाका लगेच नंबर 12 आणि मला सांगा काय आहे आन्सर. वन लास्ट सम ऑफ द टाइप, one last sum of the type, and that is difficult and most important. Yes, that is center radius form of the circle, or question can be given like this also. I think number 13. It is x minus a bracket square y minus b bracket square is equal to r square. This is center radius form of the circle, or direct this equation will be given. Okay, any one question. Tell me how many constants you find. That means I will specify this as how many arbitrary constants you will find here. How many arbitrary constants you find here? 2. How many times differentiation allowed? Twice. R is fixed. So only 2 times differentiation allowed, not 3 times. Huh? Yeah, let us go for it. पहा कसं करायचंय, फक्त लक्ष द्या, थोडं वेगळं समय आहे. एक्स मायनस ए ब्रॅकेट स्क्वेअर प्लस वाय मायनस बी ब्रॅकेट स्क्वेअर इज इक्वल टू आर स्क्वेअर, अँड आय विल कॉल दिस एज नंबर 1. आय विल डिफरन्शिएट दिस. डिफरन्शिएटिंग विथ रिस्पेक्ट टू एक्स काय येणार आहे बघा. 2 इंटू ब्रॅकेट एक्स मायनस ए प्लस 2 इंटू ब्रॅकेट वाय मायनस बी इंटू डेरिव्हेटिव्ह ऑफ वाय इज y1, b is 0 is equal to derivative of r square is 0. I'm just differentiating this. So derivative of x minus a bracket square is 2 into bracket x minus a. Y minus b bracket square is 2 into bracket y minus b into derivative of y is y1. B is 0. I will call this as number 2. Correct? Again differentiating. So again differentiating with respect to x. Check this carefully. I can cancel this 2 throughout. And now I will go for derivative. Differentiating first. 2 cancelled. Now again derivative of x will be 1 minus a will be 0. UV rule y minus b, correct na? Y minus b into derivative of y1 is y2 plus y1 into derivative of y minus b is y derivative is y1, b will be 0 is equal to 0. So I got it like this. 1 plus y minus b into y2, correct, plus y1 square is equal to 0. Now check. Y minus b into y2 is equal to minus 1 minus y1 square. So y minus b is equal to minus into bracket 1 plus y1 square upon y2. I will call this as number 3. इथपर्यंत सगळ्यांना कळलं का मी काय केलं? I differentiated this. 2 cancelled. याचा डेरिव्हेटिव्ह 2 इंटू ब्रॅकेट एक्स मायनस ए, 2 इंटू ब्रॅकेट वाय मायनस बी, वायचा डेरिव्हेटिव्ह y1, कारण चेन रूल आहे, याचा 0. मग मी परत घेतला एक्सचा 1, ए चा 0. सगळ्यांना कळतंय ना? y1 हे युव्ही रूल होणार, u डेरिव्हेटिव्ह v प्लस v डेरिव्हेटिव्ह u, करेक्ट. मग मी y मायनस बी ची व्हॅल्यू काढून घेतो, बाकी सगळं उजवीकडे टाकलंय. आता मी काय करतोय बघा. मी या 2 मध्ये ह्या y मायनस बी ची व्हॅल्यू टाकणार आहे. कशी बघा. सो फ्रॉम 2, लक्ष द्या सगळ्यांनी, फ्रॉम 2. आता मी ही जी y मायनस बी ची व्हॅल्यू आहे ना, ही मी 2 मध्ये टाकणार आहे. कशी? तर हे 2 आधी मी लिहून घेतो. x मायनस ए इज इक्वल टू, हे इकडे जाऊन मायनस होईल, मायनस ऑफ y मायनस बी इंटू y1, हे मी इकडे दिलं. आता y मायनस बी ची व्हॅल्यू माहिती आहे काय? y मायनस बी ची व्हॅल्यू ही बघा. y मायनस बी ची व्हॅल्यू काय ती? मायनस ऑफ 1 प्लस y1 स्क्वेअर अपॉन y2 इंटू y1. मी y मायनस बी ची व्हॅल्यू टाकली, हे मायनस मायनस झालं प्लस, म्हणजे आलं 1 प्लस y1 स्क्वेअर्ड इंटू y1 अपॉन y2, आणि याला मी नंबर 4 म्हणतो. आता तुमच्या लक्षात आलं असेल तर माझ्याकडे y मायनस बी ची व्हॅल्यू आहे, माझ्याकडे x मायनस ए ची व्हॅल्यू आहे. ह्या दोन्ही व्हॅल्यू मी इथे टाकू शकतो का? कळतंय का सगळ्यांना? या दोन्ही व्हॅल्यू मी नंबर 1 मध्ये टाकू शकतो का? मला y मायनस बी मिळालंय, x मायनस ए मिळालं, मी हे दोन्ही व्हॅल्यू इथे टाकतो, म्हणजे 1 बिकम्स, अँड दॅट इज द बॅक सबस्टिट्यूशन प्रोसेस. काय होतंय बघा. एक्स मायनस ए काय हाय, काय बघा त्याचा स्क्वेअर ना, म्हणजे येणार 1 प्लस y1 स्क्वेअर स्क्वेअर y1 स्क्वेअर अपॉन y2 स्क्वेअर, करेक्ट ना? कारण याचा स्क्वेअर आहे, याचा सुद्धा स्क्वेअर म्हणजे मायनसचा स्क्वेअर प्लस 1 प्लस y1 स्क्वेअर अपॉन y2 स्क्वेअर, बरोबर ना, is equal to r square, and this is your final answer. Everybody understood this last and little difficult sum of bag substitution? हा स्क्वेअर आत हवाय, आत पण स्क्वेअर हवाय. दिस इज y1 स्क्वेअर अँड ब्रॅकेट स्क्वेअर ऑल्सो. हा जर तुम्ही इकडे दिला तर ऑर्डर 2 डिग्री 2 होईल, बरोबर ना रे, ऑर्डर 2 डिग्री 2 होणार. इफ यू शिफ्ट दॅट ऑन राईट साइड इट विल बी ऑर्डर 2 अँड डिग्री 2. येस, इथे आपला टाईप 1 चा कम्प्लीट पार्ट संपलाय. येस, सो विल मीट इन द नेक्स्ट क्लास. आजचा सेशन मी संपवतोय. थँक्यू व्हेरी मच. होप आजचा टॉपिक सगळ्यांना कळलाय. विल मीट इन द नेक्स्ट क्लास. थँक्यू ऑल.